Question: what if we have a slightly more complicated exponent, such as 3 to the 2/3 power? How can we write this in radical notation? So 3 to the 2/3. We noticed that the denominator is the same as the index, right? So that would be a cubed root of 3. And what about that extra number 2? That would stay with the radicand in the base, right? So you'll see that 3 to the 2/3 is this value, and the cubed root of 3 squared is the same value if you put that in your calculator. So in general, we define a to the m over n as the nth root of a to the m, where m and n are both natural numbers greater than 1, and m over n is in its simplest form. And this is actually important, that the rational exponent m over n is in the simplest form. So, for example, if it was 2/4, you would simplify that first to 1/2. Okay. So let's use radical notation to write the expression and simplify if possible. So example A, 9 to the 3/2 says this can be written as a radical where the index is 2, so it's understood, and the radicand is the base with the numerator exponent. And these can be done in any order for us to simplify. We can do the square root first and then cube, or we could do the cubed root or the cubing first and then square root. Whichever one we choose will depend on what makes this easier. In this case, it's easier for me to do the square root of 9 because that's 3. And then I can evaluate the cube of 3, which is 27. So that's our simplified number here. In example B, negative 32 to the 2/5. So we need a radical where the index is the denominator of 5. And the radicand is the base with the numerator exponent. So again, I can do these in any order. It's going to be easier for me to do the 5th root of negative 32 first and then square that number, because the 5th root of negative 32 is negative 2. We saw that before. And if I square negative 2, that's 4. For C, negative 81 to the 3/4 power, so we need a radical where the index is 4 and the base 81 with the numerator exponent. What about that negative? That's just in front, right? It's a negative in front of the radical then. Okay, so again, I can do the 4th root of 81 first and then cube that. The negative just stays in front. So the 4th root of 81, well, 3 times 3 times 3 times 3 is 81, so the 4th root is 3. And if I cube 3, that was 27. The negative stays in front, which makes this a negative 27 here. Example D, 1/4 to the 3/2. So we need a radical. The index is 2. And the radicand is the base with the numerator of the exponent. So I can do the square root first and then cube that, because the square root of 1/4 is 1/2. And raise that to the 3rd, so multiply 1 times 1 times 1 over 2 times 2 times 2. That'll be 1/8 simplified. For example E, then, I need a radical where the index is 7. And the radicand is the base with the numerator exponent. And I can't really simplify that, so I'm going to leave that as it is.